All right, so Dalton said everything is made out of atoms. So let's take a look at an atom. And what we find is that it can actually be subdivided further into smaller parts. So maybe you've seen something like this picture on the left here that indicates the different parts of an atom. But we're just going to kind of go over it here as well. And so I'll draw this little center with some particles in there. And then on the outside, some particles kind of going around in this orbit. So in the center here, we have what's known as the nucleus. And so the nucleus makes up the mass of the atom. Almost all of the mass in the atom is located in the nucleus. And inside the nucleus are two types of particles. The first type of particle is a proton, and then the second type of particle is a neutron. So in the center, you have the nucleus. That's where all the mass is, and it's made out of protons and neutrons. And then flying around this nucleus, you have what are known as electrons. And so while the nucleus makes up most of the mass of the atom, the electron actually makes up most of the volume of an atom. So one kind of mind-blowing thing that you need to think about when you see these pictures is that they're not drawn to scale. And so what this means is the nucleus is very, very tiny. Even though it makes up most of the mass of the atom, it makes up very, very small amounts of the volume. So the analogy I like here is that if the nucleus was the size of a blueberry, right? So very tiny, the atom would be the size of a football stadium. So in general, the nucleus is very tiny compared to the overall type of atom. So let's take a look at these subatomic particles, the proton, neutron, and electron, in a little bit more detail. So here we'll have the subatomic particle. Next up, we'll talk about where it's located, so its location. And then we'll talk about its charge. And then we'll talk about its mass. So in mass, we're going to talk in terms of AMU, which are atomic mass units. And so these numbers are just ways to weigh something that is very, very tiny. One atomic mass unit, one AMU, is much, much smaller than an ounce or a gram or anything like that. All right. So first we have up the electron, and you'll often see me write this as a symbol as an E, a lowercase e, with a negative sign in the top right corner. And so it is located outside of the nucleus. The electron has a charge of -1, and its mass is very, very small. As we said previously, the nucleus makes up most of the mass, and the electron is outside the nucleus, so it's very, very small. So it weighs about 0.00055 AMU. What we'll say is just much less than 1. So if you see this double less than, that means much less than. Right, so the electron weighs almost nothing. Next up, we have the neutron. The symbol for the neutron is given as an N with a 1 in the top left corner and a 0 in the bottom left corner. We'll see why later on. It is located inside the nucleus. A neutron is neutral and thus has no charge, so it has a charge of 0, and it weighs approximately 1 atomic mass unit. And then finally, we have the proton. The proton gets the symbol of a P with a 1 in the top left and a 1 in the bottom left. It, along with the neutron, is located inside the nucleus, and it has a charge of +1. The proton is positive. Like the neutron, it has an atomic mass of approximately 1. Right, so you can see that the electron weighs much less than the proton and neutron. The last thing we want to cover here real quickly is why don't electrons leave the atom? And so you should know the answer to this, and that's because opposites attract. Right, inside the nucleus, we have a positively charged proton, and then outside the nucleus, we have a negatively charged electron, and then there's going to be an attraction between the two. And thus, the pull of the protons keeps the electron from leaving. So know about the parts of an atom.